Hello everyone. Today we're going to be looking at getting started with OpenAI's API for text generation and conversations. So let's get right into it. Now, I'm assuming that at the start of this tutorial you know how to get an API key and to set up an environment. If you don't know how to obtain an API key for the OpenAI API service and you don't know how to create an environment, I have created another tutorial on how to do this. So if you're still at that stage, I will either link the video somewhere around this video now or in the description, and you can follow the instructions there and then return to this video. If you have, however, already set up your environment and you have an API key, then we can crack on. So let's get into it. So this code block here is perhaps the most basic and simple API call you can make to the API service to get one of the GPT models to generate some text. So let's go through it line by line. So first we need to call our OpenAI library, and we also have to load up the .env library. We then load .env and set our API key. Okay, now this is where the magic happens. This response block defines what our input is to the API. So we have this model parameter where we define the model that we're making a call to. Now on the OpenAI API, there are many different models that you can choose from. I've compiled this PDF and it contains a list of all the different models you can make calls to. So for example, GPT-4o is one of their more lightweight, GPT-4o is one of their more lightweight models, whereas if you use something like GPT-5.5, it's far more capable and will cost more. So you can select which model you want depending on the task you want doing. In this example, we're using the latest GPT-5.5 and we've defined an input. So this is the message that GPT-5.5 is receiving. I've just asked it to write a song about Mr. Flimbles. It was just a name that came to my head. So that's defined the input. So once we send this off via the API, when we get a response, we're going to print that response. So let's run this code now. Okay, now we've got our response. But look at this. It's a really messy JSON response. We've got a lot of extra metadata that we don't necessarily want. So we're going to need to dig into this response and extract what we're after, which is, of course, the output text. So if you want to do that, I'll just comment out this line here, print. You'll want to print response.output text. So that's telling the code, when we get this messy JSON response, we want to extract only the chunk of text that the AI has generated. So let's do that now. So now we've defined that we want to extract only the output text from that JSON response. And here's our output now. So here's our song about Mr. Flimbles. I could sing this for you, maybe in another video. Do you know what? If this gets enough likes, I'll sing this song about Mr. Flimbles. How about that? But there we go. So another thing that might be useful to you as a developer is tracking token costs. So when we make an API call to OpenAI's API, it costs us money, both for the input tokens and the output tokens. And there's also something called reasoning tokens, which are also billed as output tokens, but I believe they can be a bit more expensive. And you would use reasoning tokens for a more complex task where the AI needs to do some thinking in the background. So we can see here in this messy JSON response that it's tracked the token usage. And therefore, if it's tracked the token usage, we can estimate what our costs are going to be. So if we want to extract the tokens, I'm just going to uncomment out these things here. So here I've defined the variable input tokens, output tokens, total tokens, reasoning tokens, and cache tokens. These are all different token types that are going to be associated with your response. And I've set these variables as the values as extracted from this chunk of JSON. And these lines of code basically define where to look within this JSON response to extract those values. And then at the end, we print these values. So let's run this. Now, whilst that's loading, because tokens are calculated by cost per million tokens, what you can do once you've got these variables, you can, for example, let's say we want to work out the cost of the output tokens. What you'd want to do, you'd want to take your output token value, divide it by 1 million to get your token per million value, and then multiply it by the cost per million tokens. And then you can store that value somewhere. So that would give you your cost in dollars for how much that response cost to make. And then you'd have to track that somewhere. But that's a bit beyond this tutorial for now. So there we go, we got our response. So I commented out the actual responses because I didn't want them for this call, just to show you that we can extract the tokens that we used up for that call there. And then, as I said, we can go on and calculate how much that cost is. Okay, great. Let's move on to the next example. So this code block is very much the same. We load in our libraries, and there's a subtle difference, however, with the response block. So again, this is defining the parameters that for when we send our API call. Now you can see that we have a reasoning parameter and an instructions parameter. So reasoning, as you know, with the more modern GPT models, they can reason. That is, they can take time to think in the background before they deliver their final response. And we can define how much we want these models to spend thinking about their response. So you can define their effort level. And there are, I think, 5 different effort levels. I did include it in this PDF. So there's none, fastest and cheapest option. There's low reasoning, light reasoning, good default for simple tasks. There's medium reasoning, balanced reasoning, quality versus speed. And then there's high reasoning, which is better for harder coding logic and planning tasks. And then there's times high, so like super high reasoning, maximum reasoning depth, slowest and most expensive. So what you need to know, basically, for lighter reasoning, it is cheaper and faster. And for heavy reasoning, it is more expensive and slower. It depends on what task you want it to do. When you use ChatGPT, it automatically selects which reasoning level to choose from. However, with the API, there is no such automatic reasoning level option. You have to select one. Now, if we go back to our previous coding example, we didn't define the reasoning level. If you don't define the reasoning level, it just defaults to medium. So if I just remove this whole reasoning line of code and just typed medium, that's equivalent basically. I can either define medium reasoning or get rid of it. It's the same thing. Okay, and then we can add instructions. So instructions would be a hidden prompt that perhaps the user wouldn't see, giving instructions to the system how to respond. So for example, in this one, I've instructed the model to talk with over-the-top corporate jargon, say nothing in lots of words. And then we have our input here. So talk about hitting this quarter's targets. So if I run this code now, it will apply medium reasoning effort and consume a few more tokens. And I've given it some instructions to, again, talk with over-the-top corporate jargon. And then here's my actual input. Let's see how that responds. So something to know, after this example, we're going to look at conversations where we maintain a constant conversation state between subsequent prompts. With the examples I'm showing you now, these are just kind of like one-time question and answer responses. So if I were to submit another response, it wouldn't remember what I previously asked it. It's like it's got blank memory. So after this example, we are going to look at maintaining memory between conversations. But an important thing to know is with the instructions, you have to submit the instructions every time. It's not like it remembers the instructions from the first prompt you gave it, and then you don't need to give it the instructions again. Anyway, whilst I was explaining that, the prompt came through. So it's written this technical jargon, corporate kind of response. You can read through it if you want. Okay, great. Now let's move on to our third example. So in our previous examples, as I said, they were one-time question and answer responses. Now we're going to look at maintaining a conversational state. So we're going to have to introduce memory to the model. So that's done simply by adding this line here. Conversation equals client.conversations.create. What this is doing, it is creating a brand new conversation, and with that conversation will be associated a conversation ID. And we're going to use this conversation ID to track the context of the conversation as it progresses. So now, in our API request block, we define the model. Optionally, we can define the reasoning level, but because we haven't included it, it's just going to default to medium. And now we've included the conversation ID. Conversation equals conversation ID. So now it's creating and storing each of our prompts and the model's requests. So now it maintains conversational continuity. And we've got some instructions here. So in the context of this prompt, we're pretending that this AI model is a tutor and it's going to help teach me something. So our input is explain what a Python function is, and then it's going to respond the text. So we're going to run this file. Now what I just realized is this is actually quite a bad example, because when I run this code again, it's just going to create a brand new conversation ID, and the next conversation is like it's going to be the first prompt we've made. So I'm just going to edit the code slightly just to prove the concept. So we got the conversation ID here. If I just copy that and remove this line here and this line, and then paste in the conversation ID here. Okay, now it should maintain a conversational state. So it's explained to me what a Python function is. Now I can ask, well, I can just say, okay, my name is Bob. Can you explain what a for loop is? And then we'll run this code. Okay, I just had to make sure that this conversation ID was between quotation marks. Gave me a little error, but that was all. So now it's saying, sure, Bob, and then it explains what a for loop is. So now to prove that it's maintained conversational continuity, if I delete this input now and ask, what is my name and what two concepts have you just explained to me? We run this again, we will see now that within this conversation, it's been able to remember what we've discussed. So let's look at our final example now. So obviously it's a bit cumbersome and not at all useful to type in a new input every time and run the code, stop the code, run the code. So we want to have a conversational loop. So this is how to introduce a conversational loop. So again, we're starting a brand new conversation. We're saving that conversation ID. Now I'm defining the user input, and then we're going to enter a while loop. I needed to define a user input because if I hadn't defined a user input, it would have errored out at this. It would have said, well, no variable called user input has been defined yet, and it'd break. So we had to define a blank user input variable here. And basically this loop is saying, while the user input does not equal /by, we're going to continue the conversation. So we're going to ask the user to input a message. Then it's going to check, does that input equal /by? Basically, I'm defining that if we want to exit the conversation, we got to type /by, and then it'll break the loop and end the conversation. So if the input is not that, then we can continue the conversation. So this break command would just break out of the loop if the input did equal that. However, if the input is anything but this command to exit the conversation, then we'll submit our response. So we're defining the model, we're defining the conversation ID, and we're saying here, you are a helpful Python tutor, explain things simply, and then we submit the user's input as defined up here. And then it's going to print the assistant's response, and it's going to keep looping around until I decide the conversation's over. And then when I eventually do type this command to end the conversation, it's just going to print conversation ended. So let's run this. So I'm going to type my message here. Hi, I'm Bob. Looking forward to learning with you. So there we go. It's responded. And now to prove that we're maintaining a conversation, I'd say, thanks, just testing your memory. What is my name? Also, can you give me a general explanation of what a function? Okay, we're going to submit that, and now it's going to think about its response for a while. There we go. So the assistant said your name is Bob, so it's remembered it from our previous prompt, therefore proving that the conversational state is being maintained, that it has memory and context within this conversation. And it's just going to keep looping around until I exit out of the conversation by typing this command. There we go, conversation ended. Now, something to understand, in this code loop, every time I run it, so when I click run now, it won't remember my previous conversation because we're creating a brand new conversation ID. So if you wanted to maintain your conversation ID across different sessions, you'd have to store that conversation ID somewhere and then load it back in. And by the way, I believe conversation IDs are only stored by OpenAI for about 30 days. So we'll cover this in another tutorial, but for now, know that that conversation will only be available for 30 days. And if you want to maintain that conversation for a longer period of time, you're going to have to manually store the conversation somewhere and then submit it as an input later on. But for now, that's the end of this tutorial. So if you enjoyed that and you're looking to learn more about the API, I've created some PDF documents to both explain the different models, when you might want to use them, the reasoning effort, and also this one with all of the code examples that we've gone through today. These PDFs, as well as this video, will be available on my Skool community. It's free to join, and I'm looking to create a community of like-minded people who are looking to learn about how to use the API, to bounce ideas off each other, and to share our projects, and to help each other out. So if that sounds like something you're interested in, oh, by the way, I've got to mention that I am posting tutorials in there too. So if that is something you're interested in, it's completely free to join. Click the link in the description. You can get access to these resources that I've made. And again, it's a perfect place to connect with people with looking to develop these skills, or with people who already have these skills and to learn off each other. I'd really recommend you do it. So yes, if you enjoyed that, subscribe, join the Skool community, and I'll see you in the next one.